So, here we're going to start on daily lessons, the 129 through 133. So we talked about position, and that corresponds with the S of t. Sometimes it's called S of t, sometimes X of t, sometimes P of t, but for right now I'm going to call it S of t. So we've got position. If you take the derivative of position, you get velocity. So velocity is the same thing as S prime of t, or just V of t. If I take the derivative of that, so we're finding the rate of change of a rate of change, we get the second derivative of position, or the derivative of velocity, or we can call this acceleration at time t. So, how this works is the same relationship that happened between f prime, f double prime, still happens, it's just position, velocity, acceleration. So, let's go with this one first. Velocity. If velocity is greater than 0, I want to know what's happening with the position. So the easiest way to think about this is velocity is the same thing as, let's say, if this is position as p of t, velocity is p prime of t. So if p prime of t is greater than 0, so the derivative is greater than 0, p of t, just like it's always been, be increasing. Except if we're talking about in terms of increasing, in terms of velocity, increasing, I can also say velocity, if it's greater than 0, the particle is moving right. Remember I said these are super boring particles, they don't really have any real world connections because they move right, they move left. Eventually we're going to get wild and crazy and they're going to move up and down, but for right now, moving right, moving left. So, as p prime of t is greater than 0, that means the position is increasing, which means that the particle is moving to the right. So, likewise, if I have p prime of t less than 0, position function is decreasing, which means the particle is moving left. Okay, so same as before, if p prime of t is changing from positive to negative, that means position is going to be changing from increasing to decreasing. Ooh, very exciting. There's a relative max. On p of t. And this also means the particle is changing from increasing, or from moving right to moving left. So a particle is changing directions. And specifically right to left. Over here, same thing. From negative to positive, that means the function is changing from decreasing to increasing. And by the function, be careful about saying that because position is a function, velocity is a function, and acceleration is a function. But if this position function is changing from decreasing to increasing, because velocity, the derivative, is changing from negative to positive, there's a relative min. And again, the particle is changing directions. But we have a boring particle, so it's just moving from left to right. There's a brief instance when the velocity is 0 because it has to change from left to right or right to left if it's changing from positive to negative or negative to positive. Which means p prime of t, where velocity is equal to 0 or undefined, these are the critical values. They're the ones we put in our chart when we're creating when we're seeing whether the original function given or the position function is going to be increasing, decreasing, max, mins. If I've got is equal to 0 is undefined, these are my critical values of p of t, which means the particle is possibly at a relative max, could be a relative min. Here, this could be an undefined part for p prime of t. It still could be a cusp or a sharp turn, that's okay. But what's happening is that the particle stops for a little bit. So particle stops. In many cases, it could be changing from positive to negative, which means it changes from right to the particle is changing from right to left. Or it could be changing from negative to positive, which means the particle is moving from left to right. Or it could just be stopping. It could be a horizontal tangent of the original function. So it could mean that the particle is going to the right, stops, continues moving to the right. Okay, talk to each other, see if you have any questions.